We're talking about measures of central tendency, and in the last video we discussed the mean. In this video we're going to discuss the median. So the median of a variable is a value that lies in the middle of the data. And that's when we arrange the data in either ascending or descending order. Doesn't matter which one. But the data have to be arranged in order. So to find the median, the data must be quantitative. So again, just like the mean, we cannot find the median for categorical or qualitative data. So find the median of each of the following data sets. Well, the first thing we have to do is rearrange them in order from ascending to, from smallest to largest or largest to smallest. I like to do it smallest to largest. So we have 62, then 68, 71, 77, and sometimes I put little check marks by them to make sure everything gets counted, 82, and 90. So we need to find the exact middle of this data set. Well, that means we would just go crossing off from either end. So if I cross one off on the left, I cross one off on the right. I cross one off on the left, I cross one off on the right. Now I'm down to two data values. So what I need to do with those two data values is find the mean of them. So I would do 71 plus 77 over 2. And that gives me, well, let's see, go to the calculator. 71 plus 77 equals, so that's 148 over 2. And if we divide by 2, I think we're going to get 74. 74. So the median is 74. So that was when we have, this is when either our population size or our sample size is an even number. Then we arrange them in order and find the mean or average of the two middle numbers. What happens when our population or our sample size is an odd number, though? Well, here we have another example where it's odd, and this one is already arranged in ascending order for us. That's nice. So again, we just go in and we cross off at either end. So one from the left, one from the right. Then do it again, one from the left, one from the right. And you see this time we're left with a single value in the center. So here, the median is that number, which is 206. Okay, now we need to talk about resistance and which measure it's better to use. So let's find the mean and the median of the following two data sets. We have 174124348, and the second data set is exactly the same, except instead of a 48, we have a 9. So let's find the mean. And we'll assume again that these are samples. And so we're finding X bar for the mean. So X bar is 1 plus 7 plus 4 plus 1 plus 2 plus 4 plus 3 plus 48, all divided by 8, because there's 8 of them. So that gives us, I don't know, let's go to the calculator. 1 plus 7 plus 4 plus 1 plus 2 plus 4 plus 3 plus 48. So we get 70 over 8. So let's take our 70 and divide by 8. And we get a mean of 8.75. Now let's find the median. So remember, first we have to arrange these in ascending order. So 1, 1, 2, 3, 4, 4, 7, and a 48. So if we do our crossing off from either end, 1 and 48 are gone, 1 and 7 are gone, 2 and 4 are gone, so we're left with 3 and 4. So the median is 3 plus 4 over 2, which is 7 over 2. And if you put 7 over 2 in the calculator, we get 3.5. Now, you guys should pause the video and find the median and the mean for the data set in part B on your own, and then you can restart the video to see if you got it right. So I'm going to assume that you've done that. So we have X bar is 1 plus 7 plus 4 plus 1 plus 2 plus 4 plus 3 plus 9 all over 8. And so if we add all those up, 1 plus 7 plus 4 plus 1 plus 2 plus 4 plus 3 plus 9, we get 31 over 8, which is 3.875. Now let's find the median. So arrange them in order again. 1, 1, 2, 3, 4, 4, 7, 9. 4, 4, 7, 9. Now we're going to cross off from each end again. So the 1 and the 9 are gone. The 7 and the second one are gone. 2 and one of the 4s is gone. So we're left with the median is 3 plus 4 over 2 again, which is 3.5 when we put it in the calculator. So why is all that important? Well, what did we notice? These data sets were exactly the same, except for in the first one there was a 48 as the last number, and in the second one there was a 9. Oops. And this should say 9. And what happened? The means were very different, right? Our means, one of them was 8.75 and the other one was 3.875. But our medians were exactly the same. So the only difference between the two data sets, again, is that there's a 48 in the first problem and it's changed to a 9 in the second problem. So what this shows us is that the mean is affected by what we call outliers. However, the median is not affected by the outliers. And an outlier is just a data value that is extreme, meaning much higher or lower than the rest of the data. And in a few more sections, we'll have a way to determine exactly what is an outlier. So, a numerical summary of data is said to be resistant if extreme values relative to the data, meaning the outliers, do not affect its value. So, the median is resistant, but the mean is not. And we know that because the mean changed greatly when just one data value changed a lot. So when data are skewed, there are extreme values in the tail. So in these pictures, I'm going to highlight in yellow. Outliers would be out where I'm highlighting in yellow on each of these. So the outliers move the mean in the direction of the tail, but the median doesn't change. So these aren't the best pictures, but you see when it's symmetric, that nice normal bell-shaped curve, the mean and the median equal each other. And they're both right smack in the middle. If it's skewed right, the median stays closer to the middle, but the mean gets pulled towards the right tail. And if it's skewed left, the median stays pretty close to the middle. But the mean, again, gets pulled towards the tail, which means it moves left. We'll end this video here, and we'll start talking about the mode in the next video.